I love this time of day when the sun is setting and the stars appear. And each new star I see makes me wonder, is anybody out there? If so, where are they? What are they like? Hello everyone, I'm Suzanne Ford. Let me ask you, have you ever wondered if there's life out there in space? Well, what if I told you there is life up there on that bright object shining in the west? Would you believe me? Well, it's true. There is definitely life up there, intelligent life. In fact, look, they've created robots to investigate other worlds, or maybe invade them. Wait a minute, are we being invaded? Well, that depends on your point of view. That bright light up there in the west is Earth. We are on Mars. NASA sent this rover to look for signs of life. But why here? Why is anybody looking for life on Mars? That question is the start of one of the great astronomical detective stories. Our story begins back in the 1890s with this image of Mars. It's fuzzy because this is all astronomers of the time could see. Still, they were confident Mars has polar ice caps, changing seasons, and a 24-hour cycle of day and night. To them, Mars looked a lot like Earth. Mars became such a passion for astronomer Percival Lowell that in 1894 he built his own observatory in Flagstaff, Arizona, and assembled a team just to study the planet. He was most intrigued by the mysterious lines he glimpsed crisscrossing the surface. Lowell mapped and named them and concluded they were canals built by a very advanced society. Lowell imagined a great water crisis on Mars. Lowell believed Martians were channeling water from the polar ice caps to the thirsty cities of the equator. His theory caught on. In 1906, a New York Times headline screamed, "There is life on planet Mars." Mars mania was born, and the public ate it up. Lowell imagined resourceful Martians who cooperated to avoid extinction. But science fiction writers twisted the story into desperate Martians, looking toward Earth for a new home. In 1938, Orson Welles terrified listeners with his radio broadcast of an imaginary Martian attack on unsuspecting planet Earth.
Nothing's happening. Ladies and gentlemen, it's terrific. Something wriggling out of the shadow like a gray snake. They look like tentacles to me. Now it's another one, and another one, and another one.
Since that time, stories of invaders from outer space have been an endless source of earthling entertainment, even after scientific discoveries cast doubt that civilization ever existed on the red planet. The day of reckoning came in 1965.
3, 2, 1, 0. Liftoff. We have
liftoff.
The world watched with great expectation as Mariner 4 approached Mars. At last, the mystery of Lowell's canals would be solved. Mariner snapped 21 photos of the red planet and beamed them back to Earth. The result was a giant letdown for much of the public. There were no cities, no canals, no signs of civilization, just a dry, barren, cratered wasteland. Now, the New York Times announced, Mars is probably a dead planet. But is it really? To solve the mystery of life in the universe, we need to rethink our detective work and answer some fundamental questions. What is life exactly? What does it need? Where does it thrive? For answers, let's go to the one place in the universe we know life exists, our own backyard. What does it mean to be alive? Well, it seems pretty obvious. Things that are alive move around. They drink water or absorb it in some way, and they eat. Then they turn what they eat into energy to grow and reproduce. And they recycle their waste back to the environment. This is true of all forms of life, from people to dogs to bugs to plants. These are the signs of life on Earth, and we expect they will be the same anywhere in the universe. But there's a catch. Animals and plants have only been around a very short time compared to Earth. What does life look like for most of Earth's history? The answer is simple and very tiny. A drop of water is a window on Earth's past. It's full of single-cell microbes like those that sprang to life 3.5 billion years ago, and multi-celled organisms that evolved 500 million years ago. So for most of Earth's history, if we'd come looking for life, this is all the life we would have discovered if we'd known where to look. It's a menagerie of alien-looking creatures that do exactly what we do. They absorb water, move, grow, eat, recycle waste, and reproduce. Even this microscopic tardigrade does all those things. Living organisms are made of cells, the smallest units of life. Inside each cell is a tiny chemical factory that creates and stores energy using the essential elements of life, mainly carbon, hydrogen, oxygen, nitrogen. In the nucleus of every complex cell are strands of DNA molecules with the instructions each organism needs to develop and reproduce. Water is what allows everything to move and interact. Take away water, everything stops. Cells can survive as single organisms, like microbes, or work together in larger, more complex creatures like us. Cells are responsible for every sign of life, from the wriggling of the humblest bacteria to the greatest achievements of human genius. Now that we know what life is, where should we look for it? The evolution of life on Earth has been guided by its environment. Where we live determines so much: how we move, how we mate, what we eat, and what eats us. Life thrives in water-rich environments that provide food, shelter, and protection from predators. But environments can change. When they do, life must evolve to fit in. Life can exist in some pretty extreme places, far below the Antarctic ice sheet. Microbes flourish in an underground lake. Elsewhere, beneath the earth, slimy bacteria thrive in caves more corrosive than battery acid. And deep in the ocean, under crushing pressure, volcanic vents pour out scalding heat from below Earth's crust. And yet, life is abundant here. Some even speculate this is one place where life on Earth could have begun. No matter how strange life is, or where we find it, life as we know it needs energy, raw materials, and water to transport molecules. Earth has it all, and it's brimming with life. But why? What's so special about this planet? Here's the first clue. Earth is the right distance from the sun to have liquid water. If the sun were much closer, the oceans would boil away. Much farther away, we'd be covered in ice. Earth is in our sun's Goldilocks zone. Not too hot, not too cold, where the temperature is just right. Earth's thick atmosphere blankets the planet. It is namely nitrogen and oxygen, important components of life. Earth's core is made of iron, which creates a magnetic shield, protecting us from harmful solar radiation. Although the shield is invisible, shimmering aurorae around the poles tell us it is there. Earth has a large moon close by. Its gravity stabilizes our planet's rotation and climate. And finally, Earth has been around a long time, 4.5 billion years. That's long enough for its warmth, protection, and stability to provide a home for the evolution of life. We came to Earth for clues that would help us look for life. Now we know the simplest and most abundant life forms are microscopic, and they flourish in watery environments. So let's take a closer look at our old friend Mars, on the outer edge of the Goldilocks zone, to see if we can detect any signs of life. We know we're never going to find the canals and great cities that Percival Lowell imagined. But the discovery of even the tiniest microorganism beyond Earth would revolutionize our understanding of life in the universe. Over the last 50 years, our spacecraft have photographed the entire surface of the red planet, and our detective work is starting to pay off. This view of Mars was captured by the Mars Reconnaissance Orbiter, flying over terrain that the Mariner mission missed. It shows canyons, river valleys, and floodplains that look as if they were formed by flowing water. On the ground, rovers analyze the surface chemistry of the planet. It turns out many of the minerals are the same ones that on Earth form in water. Percival Lowell was right about one thing. Mars did have a water crisis, but it was over 2 billion years ago. Back then, Mars had a huge ocean and all the necessary ingredients for life. But did life actually form before the oceans dried up? We hope to find out soon. NASA's rover, Perseverance, is now digging deeper for traces of microscopic life. But Mars is just the first chapter in our detective story. Our search for signs of life is now taking us well beyond the Goldilocks zone to the outer solar system. Why there? Because our space probes have discovered liquid water where we never expected to find it. Jupiter has at least 80 moons, and 4 of them are the size of a small planet. They're so far from the sun that most of them are frozen on the surface. But Jupiter's enormous gravitational pull stretches 3 of these moons as they orbit, heating them from the inside, and that heat makes them potential homes for life. Europa is one moon that shows great promise. That's why NASA will soon be sending the Europa Clipper to take a closer look and to search for a future landing spot. But Europa's crust is riddled with fault lines. On Earth, fractures like this are caused by huge tectonic plates shifting over a mantle of warm, flexible rock. On Europa, these plates are made of ice. Beneath the ice is something astounding. A liquid ocean with more water than all of the oceans on Earth. If there is life on Europa, we'll find it here in its salty sea. We're finding water farther and farther from the sun, but most of it is frozen. Saturn's famous rings are made of billions of particles of orbiting ice. Saturn has even more moons than Jupiter, and one of them put on a show that grabbed NASA's attention when the Cassini space probe flew past the icy moon Enceladus. It discovered towering jets of water, laced with the kind of organic compounds found in living things. This tiny moon seems so habitable that NASA chose to crash the probe into Saturn to protect Enceladus from any hitchhiking Earth microbes. Farther from Saturn orbits a world that seems more Earth-like than any other place in our solar system. Saturn's largest moon, Titan, the only moon with a thick, nitrogen-rich atmosphere similar to Earth's. It is so dense that humans could fly through it, with wings attached to their arms. Underneath this thick layer of haze are lakes, mountains, and river valleys that make Titan look a lot like Earth. There's one major difference. Though rain pours down on Titan, it's too cold to be water. It's liquid methane. On Earth, methane is a natural gas that we use to heat our homes and stoves. Here, as a liquid, methane carves canyons on Titan's frozen surface and fills shallow seas. Life needs a liquid, but does it have to be water? If we were to find cells on Titan that consume energy and reproduce, then we would call that life. It might not be the same as life on Earth, but it would be life. From our home on Earth, we've launched nearly 100 space probes to help us do our detective work. So far, they found almost a dozen places in our solar system that have or had the right conditions for life. And the best may be yet to come. With our ever more powerful space telescopes, we are finding more places that could harbor life than we've ever imagined. We're not just looking for microbes, we're looking for worlds that are even more Earth-like than anything we found in our solar system. And the stars are sending clues. The stars are the new hunting ground in our search for signs of life. Every star you see in the night sky is actually a sun. They appear tiny because they are trillions of miles away. They are so far from Earth that we describe their distances not in miles but in light years. The distance light can travel in 1 year, about 6 trillion miles. High in the northern sky is Polaris, the North Star. Polaris is 434 light years from Earth. That means we are looking at light that left the North Star in 1588. By comparison, our sun is just 8 light minutes away. The stars are so far away that most telescopes can't see planets orbiting them. But creative detective work tells us the planets are there. Not far from Polaris is the constellation Cygnus, the Swan. A faint star here dims at regular intervals. That tells us there's a planet circling it, blocking its light. A star in the constellation Libra is sending out light that varies in color. That tells us that the gravity of an orbiting planet is making the star wobble. Using these and other signs, in the last 30 years, astronomers have identified over 5,000 planets, circling stars in virtually every constellation in the sky. And they've just begun counting. In our search for planets like ours, there is one more critical component to consider: time. It takes time to create the elements that support life. So now our quest is to find planets like Earth that have had enough time to develop life. In the southern sky is the constellation Scorpius, the Scorpion, featuring a bright red star, Antares. This supergiant is running out of time. It's going to explode, perhaps in our lifetime. When it does, the death of this star will scatter the elements of life and begin the creation of new places where life could form. It all starts like this. This catastrophic explosion is called a supernova. It expands at 70 million miles an hour, compressing everything in its path. These stellar ashes contain the atoms required for life. Elements like iron, carbon, nitrogen, and oxygen. Gravity pulls in swirling gas and dust to form a protoplanetary disk, triggering the creation of a new star and planets, following the laws of physics. inside this volatile disk. Hurtling meteorites bombard a newborn world, adding to its mass of chemical complexity. Earth started like this. Eventually, this planet may become a home for life too, but it needs more time. A lot more time. So let's leave this tumultuous newborn and travel to a world much more suitable for the formation of life. In the constellation Cygnus, the Swan, time is on the side of this planet, Kepler 452b. It's been warm and stable for 6 billion years, 30% longer than Earth, and certainly long enough to establish life. It orbits a sun very similar to ours, and it's in the Goldilocks zone, so water could be liquid on its surface. Perhaps it's just like Earth and filled with life. We don't know yet. But the more planets we discover, the more likely we will find planets like ours. 40 light years from our own solar system, we found planets that have had even more time to develop. In the constellation Aquarius, there's a star called TRAPPIST-1. It's a red dwarf star, smaller, dimmer, and cooler than our sun. 70% of the stars in our galaxy are like this one. By observing how TRAPPIST-1 dims as planets cross in front of it, we've learned it is circled by 7 Earth-sized planets. We think 3 of these are in the Goldilocks zone and are rocky planets with iron cores and liquid water, just like Earth. But there are differences. The planets orbiting TRAPPIST-1 are very close to their sun. Its strong gravitational pull locks them in an orbit with the same side always facing the light. Shadows never move. Wherever you are on this planet, it's the same time of day forever. Still, these planets have had time, up to twice as much as Earth. So, with water, minerals, and energy from their sun, they could have all the right ingredients for life. The most active star and planet-forming region we know about isn't in our own Milky Way galaxy. It's in a neighboring galaxy called the Large Magellanic Cloud, 160,000 light years from Earth. It is so far from Earth that if we tried to fly there in our fastest spacecraft, going 24,000 miles per hour, it would still take us 4.5 billion years to get there. But with our powerful space telescopes, we have a good idea of what we might find. The Large Magellanic Cloud is an astronomical treasure trove of supergiant stars, supernovae, and luminous clouds of gas and stardust. If life developed here, on a planet in this faraway galaxy, it's because the ingredients were here, and there was plenty of time. Life here could look quite different from the life we know. Plants might be purple to maximize the light from a weaker sun. Communication might use infrared or sonar or bioluminescence. If there were intelligent creatures here, able to look back at us in the Milky Way galaxy, they would see light that left Earth 160,000 years ago, in the Middle Stone Age. They might detect signs of life, but they wouldn't detect any signs of us today. They could be wondering, is anybody out there? But they couldn't tell. Neither can we, at least not yet. But we now estimate there are over 100 billion planets in our own Milky Way galaxy alone. Plenty of places to continue our search. We know what it took to put life in the universe. It took galaxies, stars, planets, molecules, atoms, and time. Lots of time. If we do find signs of life beyond Earth, even in just one place, it will verify what we already suspect. Life in the universe is not an accident. It's inevitable. It's a fundamental consequence of cosmic evolution.
As the Secretary General of the United Nations, I send greetings on behalf of the people of our planet.
Our most distant spacecraft, Voyager 1, launched in 1977, has recently left our solar system.
Konnichiwa, o genki desu ka?
Herzliche Grüße an alle.
It's carrying a golden record with our greetings to anyone who happens to find it.
Hola y saludos a todos.
Hello from the children of planet Earth.
It's our ambassador to the universe, announcing that after nearly 10 billion years on at least one watery world, the universe came to life. Now life on Earth wants to know, is there life out there? If so, where is it? What is it like? When we put our eyes to our telescope, send spacecraft into the solar system to ponder distant worlds among the stars, we'll know signs of life when we see them. Life is the real marvel of the universe. The iron in our blood and the calcium in our bones were made in the stars. Every atom in our DNA is the product of nearly 14 billion years of cosmic evolution. That story of the universe is written in the sky. It's not just a story about aliens and whether we're alone. It's a story about what it took to put life in the universe. And that's why we'll keep looking out there for signs of life.